Good morning. Today we'll study about van der Waals equation and its derivation P plus A by B square B minus B equal to R3. Before we study van der Waals equation, what is the use of van der Waals equation? Van der Waals equation is used to explain the real gas behavior. Real gas behavior. Okay, now what are real gases? What are ideal gases? Ideal gases are gases that obey the ideal gas equation P is equal to nRT. So what are real gases? Real gases that do not obey the ideal gas equation P is equal to nRT. If you see, all the gases are real. No gas is ideal. Okay? The gas behaves ideally only at low pressure and high temperature. Remember, the gas, real gases behave ideally at low pressure and high temperature. You see. Okay, now why all the gases are real? They do not obey ideal gas equation because there are two reasons for deviations. According to kinetic theory of gases, there are two postulates. According to kinetic theory of gases, the atoms or molecules in the gaseous state are considered as point masses. They are point masses. They do not occupy any volume. Remember, they do not occupy the volume occupied by the atoms or molecules are negligible, but it is not true. So the volume occupied by the molecules is not negligible. So van der Waals made two corrections. Van der Waals introduced and made two corrections to account for the volume. Of the gaseous molecules. Okay, and the another postulate, according to kinetic theory of gases, there exists no attractive force. See, they are point masses. There exists no attractive forces between the molecules or atoms. But in real gases, there exists attractive force between the gaseous molecules, and atoms. Okay, so therefore, he again corrected the pressure term. And he derived this equation. Now we will see what are the two reasons. We have seen volume occupied by the molecule is not negligible. There exists attractive force between the molecules. Because of that, real gases do not obey the ideal gas equation. Okay. Now, what is volume correction? What is pressure correction? Okay. One. Volume occupied by the gas molecules not negligible. Okay. Only at low pressure. The molecules are very far apart. At low pressure, the molecules are very far apart. There will be the volume occupied is very, very small compared to the volume of the vessel. And high temperature, the molecules are far away. At high temperature, the molecules have high kinetic energy. Therefore, they are very far away, and therefore the volume occupied, and also no attractive force because they are very far away. Attractive force won't be there. So real gases obey the ideal gas equation under low pressure, high temperature condition. You remember that. Therefore, this is the, for example, V is the volume, ideal gas volume or volume of the container, volume of the vessel, and minus the volume occupied by the gas molecules. Okay. Therefore, V prime is the volume correction. V effective. This is the volume. V effective is the free volume available for the gas molecules to move about, because some of the volume is occupied by the gas molecules itself. Okay. Now, how to calculate this? V prime is equal to NV. N is the number of moles. V is called the excluded volume or co-volume. V is called co-volume or excluded volume. How it is calculated? Based on his assumption that the two molecules cannot come closer than this distance, 2r. It cannot come closer than this distance. Okay, because the two spheres are impenetrable. Therefore, this sphere, this volume of sphere is called co-volume or excluded volume. How this volume is calculated, volume of the sphere is calculated? You know the formula, volume of the sphere equal to 4 pi 3 pi r cube, 4 pi 3 pi r cube. Therefore, the volume of the sphere, this sphere equal to, this sphere is not available for other molecules to move about. The other molecules cannot come it is not available. This is excluded volume. Okay. Therefore, the excluded volume equal to 4 pi 3 pi 2r whole power cube. Therefore, 4 pi 3 pi r cube and 2 cube equal to into 8. This is nothing but 4 pi 3 pi r cube is the volume of the molecule. Okay. Actual volume of the molecule. Volume occupied by the molecule. Therefore, this is for two molecules. The excluded volume for two molecules, okay, two molecules. So therefore, for one molecule it is divided by 2, therefore 4 into volume of the molecule. The excluded volume for one mole, in that case 4 into Avogadro number into volume of each molecule. Okay, so we have obtained the pressure correction term. Now let us see the volume correction term. Let us now see the pressure correction term. If you look at the gaseous vessel, the molecules at the center is experiencing attractive force and experience attractive force in the opposite direction, and there will be zero net force. There will be no net force because equal and opposite. Similarly, this equal and opposite is no net inward pull. Remember, there is no net inward pull of molecule in the body, whereas at the surface of the vessel, now you see the molecules are attracted by this, there will be net inward pull of the molecule because of the attractive force. If there is no attractive force, okay. Since there is a net inward pull, because of the attractive force of the molecules, the force decreases. The force with which the collision. What is pressure? Pressure is due to collisions of the molecules on the walls of the container. Remember that. Therefore, the force with which it collides is less. Therefore, the pressure is less. Therefore, the real gas pressure. You remember, the real gas pressure is less because of this net inward pull due to attractive force between the molecules. Therefore, P ideal equal to P real plus P prime, pressure correction term. Okay, why the real gas pressure is less? Because of net inward pull. Okay, therefore P prime, now how it is determined? P prime is directly proportional, the pressure correction term is directly proportional to density square. Okay, square of the density, but D is the density, N by D, D is the density. If density, number of molecules per unit volume is greater, then net inward pull will be greater because more number of molecules will attract. If density is less, number of molecules per unit volume is less, then number of molecules will be less, therefore net inward pull will be less. Therefore, P prime is directly proportional to density square, P proportional to N by D whole square, P equal to A, where A is a proportionality constant, N square by D square, where A and B are called the van der Waals constant. They are very, very useful because we will see their significance. What is A? A is greater if, what is the significance of A? If A value of the gas is greater, then it will be more easily liquefied. Remember, it will be asked you very various competitive examination. They will give A value for different gases. Which one is more easily liquefied? If A value is greater, remember, the gas, there will be more attractive force. P is directly proportional to A. Cohesive, where A is called cohesive pressure. A is called cohesive pressure. Attractive, due to intermolecular attractive force. Okay. Therefore, on introducing the correction term in the ideal gas equation, on introducing the volume correction and pressure correction, so P plus A N square by D square into B minus NB equal to nRT. This equation is known as van der Waals gas equation. This equation is used to explain the real gas behavior. successfully. This equation is explains the behavior of real gases successfully. So he was awarded Nobel Prize. He was awarded Nobel Prize for his work on gaseous and liquid state. So this equation is very important. Units for A and B, it is very important. There will be several problems asked. V prime, for example, V prime equal to NB. Okay, V prime equal to NB. Therefore, B, what is the unit of B? You take out B equal to V prime by N equal to volume unit is liter or decimeter cube divided by 1. 1 liter equal to 1 decimeter cube. Remember? And similarly, P equal to A N square V square. Therefore, A is taken out. A, if you take A, PV square by N square. Therefore, atmosphere liter square by mole square. Okay. What are the significances of A and B? A and B, the van der Waals constants. Using the van der Waals constant, we can calculate the inversion temperature. Okay, we'll see what is inversion temperature later. We can you can calculate the inversion temperature of the gas. The critical constants, critical temperature, critical volume, critical pressure, they are, if you know the A and B value, the relation between TA and A and B, if you know these relations, we can calculate the inversion temperature, critical constants from the van der Waals constants. Okay, thank you for watching. We will continue.